So if you're watching this video on 7.2 Law of Sine, or Sines, we just finished up a unit notes on 7.1, which is dealing with right triangle trigonometry. If we're solving right triangles, and then we've given a right triangle, we can use right triangle trigonometry and things to know. We know about angles to solve those triangles. Now, what happens in a case where you're given something, you're given a triangle, for example, a triangle ABC, that is an oblique triangle. Oblique is just another word for a non-right triangle. It could be an acute, it could be obtuse, and we're given maybe side lengths, which are A, B, and C, and we also know that those sides are opposite of angles A, B, and C, respectively. So if we are given something that's oblique or non-right, we may, in some cases, use our law of sines, which says if I could take the sine of angle A, which is right here, sine of angle A, and I divide that, or I set it up as a ratio, over its opposite side, little a, that ratio is going to be equivalent to the sine of B over the side opposite of B, or the angle opposite sine of B over its opposite side B, and that would be equivalent to sine of C all over little c, the side opposite of angle C. So since we have that relationship set up and we know it's true using the law of sines, we can take certain given pieces of information and apply the law of sines to find missing pieces of information. It's important to understand that law of sines can only be applied when I'm given two angles in any side of a triangle. Now, two angles in a side, that means maybe an angle in an included side where the sides between the two angles I know, or that also could be two angles in a non-included side. So if I have that type of information provided to me, I can use law of sines to find the missing angles and sides. Or if I have two sides and an angle across from one of those two sides, meaning that it follows two sides and a non-included angle. If that's the case and you get side-side angle, you have to be careful there because that could lead to ambiguous cases, and we're going to cover that in this lesson. So the first case we're going to talk about is angle side. Here, if I look at the information they give me and the drawn picture, they give me an angle C, which is 102. They give me an angle measure for angle A, and they say that's 28 degrees. And they give me side A, which is 27. So if I look at those corresponding angles and sides, I have a case where I have an angle, 28 degrees, an angle, 102 degrees, and the adjacent side, 27. So I'm going to go ahead and label that in my solution matrix here. Angle A is 28 degrees, angle C is 102 degrees, and side A, opposite of angle A, is 27 units. So obviously you can see this is not a right triangle, so we have to kind of stay away from our right triangle trigonometry, and we're going to have to apply law of sines to find the missing pieces of information. Since they give me angle A and side A, and that's located right here, these two pieces of information are already given to me, so I'm going to use that as my constant throughout this whole process. When I first start up, I want to find possibly the side that's opposite of an angle that I already know. So I'm going to go ahead and try to find sine of 102 degrees over sine C, and I'm going to set that equal to sine of 28 degrees over 27. In this case, I'm using the three pieces of information I do know to find the one piece that I can find. One equation, one variable, that makes sense. So when I cross multiply and then I divide by the sine of 28, I get C is equal to 27 times the sine of 102 degrees, all divided by the sine of 28 degrees. Remembering from last lesson, if I'm going to go ahead and plug this into my calculator now, I want to make sure that if I'm in degree mode, I'm in degree mode, or if I'm in radian mode, I include the angle symbol when I'm inputting my angles. So here, I'm in degree mode, so that's fine. We're going to then type in a fraction, which we'll have in the numerator 27 times the sine of 102 degrees divided by the sine of 28 degrees. When I click that, I find my little side, opposite of angle, actually my large side opposite of angle C, and that value is 56.255. 56.255. Always round to 3 decimal places unless otherwise denoted or told. Now the question is, now we need to find all the things located around B, and we don't know the angle or we don't know the side. So the first thing we want to recognize is something we learned last lesson 7.1, is that the angles inside a triangle always have to add up to 180 degrees. So if angle A is 28 and angle C is 102, angle B then can be found by taking away that sum from 180 degrees. So when I add 28 and 102, I end up with 130, and I take away 130 from 180, I end up with 50 degrees for my third angle. Now that I found the measure of angle B, I can use law of sines to find my missing side length opposite of angle B. Always referring back to angle A and sine A and sine of A and side little a, because those two units were already given to me and they're not an approximation, they're exact values. So whenever we have a chance to use exact values, we want to make sure we take advantage of that. So now when I cross multiply, I end up with B being equal to 27 times the sine of 50 degrees, all divided by the sine of 28 degrees. So little b, once I plug that in my calculator and I find the exact value on my rounded value, that's going to be 44.056 units. Remembering back to our triangle inequality, smallest angle opposite of smallest side, medium angle medium side, and large angle large side. Here we have a new case of angle side angle. So here when I look at the given information, I have two angles with an included side given to me. So I know in that case I can use law of sines to find my missing angles, missing angle and missing two sides. The angle might be the easiest thing to find. Angle A we know is 66 degrees, angle B we know is 34 degrees. So if I add those to get 90, 100 degrees, I can take that 100 away from 180 to find my third angle. So 180 minus the sum of 66 and 34, which is 100, so then that means angle C has to be 80 degrees. I also know that side C is 12. So now that I know C, I can kind of use that as my anchor, and I can keep using the sine law, sine of 80 degrees over 12, and set that ratio equal to my missing ratios that I'm trying to find. Sine of 66 degrees over little a, and when I cross multiply here and divide by the sine of 80, a is going to be equal to 12 times the sine of 66 degrees divided by sine of 80 degrees. Again, just plugging that in my calculator at this point gives me a quick answer for that, which is going to be 11.132. And then going back to sine of B, which I know is 34 degrees, all over little b, and that's going to be equivalent to, going back to what I know, sine of 80 degrees over 12. When I cross multiply, which you'll get pretty quick at after a while, cross multiplying here, it's going to leave me with a 12 times the sine of 34 degrees all over the sine of 80 degrees. Dropping my degree symbol. Make sure I include that throughout so I understand that they're in degrees. Plug that in my calculator, and my third side, which is the smallest of the three angles, is a 6.814. So here we talked about a case where we have angle, angle, and non-included side, and here we have angle, angle, and an included side. Either of them pretty straightforward cases for law of sines. Now, let's actually have you guys go ahead and practice number 9. You can try that on your own. Remember, if they're not giving you a picture, you want to make sure that you provide a picture if possible. So when I'm drawing this, I want to make sure that I go ahead and put some type of triangle that's oblique, we can label the parts A, B, and C. And we can find those missing pieces. 80 degrees. This is 9. Well, sorry, not 9. This is 9, because it's opposite of C. And this would be opposite of A, which would be 17. When I look at the order of those corresponding parts, I realize that I'm going to be using my side-side angle, which I have to be very careful about, because this type of possible triangle is going to have maybe one triangle, maybe two triangles, or maybe not even triangles at all, depending on the information that they give you. So you've got to be really careful about this when solving this type of problem. It's also got some calculator tracks to it, so we've got to be really careful there. Let's go ahead and fill in what we know. Side A, that's 17. And here, opposite of C, that's 9. So we're going to use this one a lot, especially when we're talking about the angle here. I have angle A, so sine of 80 degrees over 17. That's my go-to, since it's an exact value. And the first thing I probably want to find is this measure of angle C, because I already know its side length, which is 9. So I'm going to put 9 out here. I'm going to try to find the sine of angle C. Since I'm trying to find an angle measure, I'm going to go ahead and use some trig inverses as I go through this process. So I'm going to cross multiply. And when I do that, I end up with a 17 times the sine of C is equal to 9 times the sine of 80 degrees. And then when I divide by 17, I get sine of C is equal to 9 sine of 80 degrees over 17. But I got to do trig inverse to find the angle. So when I take the sine inverse of sine, that just equals my angle C. And I'm going to take the sine inverse of 9 times the sine of 80 degrees all over 17. This is a daunting calculator insert, but totally doable. You just got to make sure you take it step by step. The first is I'm going to do the sine inverse, so second sine, and then I'm going to do, inside that I have an angle, and that angle is 9 times the sine of 80 degrees, close my parentheses, all over 17, and I'm going to go outside and close out the outside parenthesis. I'm in degree mode, so that answer of 31.424 is an approximated value. Now, right now, if I look at my calculator, that value is listed at 31.42411,346. It's a long decimal, and I'm going to make sure I include all of those decimal places in my calculator or stored somewhere so that I can use that moving forward. My last part of law of sines says that the sine of b over little b, that ratio is equivalent to the two other ratios. But I don't have angle b or side b. So if I have two angles of a triangle, I can always find the third by going ahead and adding those three angles together. And they have to add up to 180 degrees. C and A I know, so I can take their sum, and if I can take that sum away from 180, then I'll find the measure of angle B. So, in my calculator, I want to make sure I go through those steps. So I'm going to add this 31, and make the screen really big here so you can see it. I'm going to take this angle of 31.424 and the whole value here, and I'm going to go ahead and add that to the other angle I know, which is 80. So I'm going to take the answer from the previous and add 80 to it. Now I'm going to take away that from 180. So to do that in my calculator, I do 180, which is 180 degrees, minus, I want to take the previous answer. So if I hit second negative sign, it allows me to select the answer from previous problem. So that is equal to 68.576. And that's my other angle. And again, I'm using all decimal places. I'm leaving it in there for me to use later. My other angle here rounded is 68.576. And I'm going to use this angle B, which I just found, and I'm going to plug that into my triangle, but I have to make sure I go back to using my angle A and my angle B here. So sine of 80 degrees over 17 is equal to sine of B, which I know what angle B is. I can put that in later on if I want to by hitting second negative sign. All over my little side b, which is what I'm trying to find. So I'm solving for this little b right here. Cross multiply and divide, which means that b, little b, is equal to 17 times the sine of angle b, which I know in my calculator is 68.57 whatever, all over sine of 80 degrees. So in my calculator now, let's get rid of this big picture. I want to go ahead and I'm going to take 17, and I might want to do that. I might want to go ahead and put that in a fancy fraction form. 17 times the sine of my angle B, which is previously entered here, so I just get second negative sign, all over sine of 80 degrees. This process allows me to find the most accurate answer possible without rounding at all. When I plug this in and I hit enter, I end up with a 16.069, which gives me the exact answer that I'm looking for, rounded to 3 decimal places, 16.069. Alright, so we covered our 2 cases, actually all 3 cases, but we have to be really careful with the side-side angle possibility, mainly because of the ambiguous case that comes with it. So, we're going to have to consider a triangle here, for example, where the measure of angle A is 35 degrees. Your notes are a little jacked up. This is 35 degree angle. This is 8 right here. This is vertex B. It's possible that when you do side-side angle, which is what we have here, there are 2 possible triangles you could have. You can have an obtuse triangle that looks like this, where angle B would be something that's obtuse. Or, if I add on an isosceles triangle here and expand the triangle, now I have the same given requirements. However, now I have something that is of an acute triangle look. So I have to make sure I include both possible triangles in my solutions, if that's the case. So we have some criteria here to walk through. If those 4 criteria are true, then you know that you have 2 triangles to find in this process. So let's walk through the first one together. If all 4 answers are yes, then there are 2 triangles possible, and we have to find both. So since we know that this is side-side angle, and we know that the angle given to me, 35 degrees, is acute, and 8 is less than 10, and 10 times the sine of 35 is less than 8, I know that there's going to be 2 triangles that I have to find in this process. So let's kind of break this down into 2 pieces. The first piece is obviously looking for the first triangle, the acute triangle that I have. So let's draw a triangle that's an acute triangle. We'll take the given angle, we'll put it right here, angle A. We want to keep that the same, it's always going to be 35 degrees. The side opposite of angle A is 8, that's going to go right there. And we'll put B here, and we'll put its little side right here, 10. So that makes this C, and that makes this C as well. So we'll go ahead and label our information on our first triangle, which is the acute triangle. And A is 35 degrees. Little a is 8, and little b is 10. So we need to use this information to find the other missing information. First thing we're going to find is obviously angle b. So sine of b over little b, which is 10, is going to be equal to sine of 35 over 8, 5 degrees. Solving for the sine of b, we're going to do sine inverse. So, following the same process as previously, we're going to do the sine inverse of, and here we're going to have a little cross multiplying, so 10 times the sine of 35 degrees all divided by 8. Now, you might ask yourself, why the heck do we have these 4 criteria? How am I going to remember all this? There's an easy way to kind of remember them logically. Obviously, side-side angle, we can kind of see from our picture that that's what we have. Is the given angle acute? We can pretty much determine that. But why is it important for 8 to be less than 10? Well, if this is an acute triangle, we want to make sure that our process is true, because mainly, when I go through this, I want 8 to be less than 10 because I want this to be true. And why would I want this, 10 times the sine of 35, to be less than 8? Well, that means I want this numerator to be less than my denominator. So when my numerator is less than my denominator of a fraction, my number, my ratio value, always is less than 1. And when I'm taking sine inverse, I want something that's less than 1. If it doesn't become less than 1, then it can't be found because it's not in my range, and that means it's not a possible triangle. So if you get an error at this point, then you know you have something that would not be a triangle at all, and it would fail the possible triangle test. But since it is less than 1, and I can go ahead and find this, I know that the measure of angle B would have to be 45.805 degrees. Now, once you get to this point, you can go ahead and finish out the process to find the values of C. Sine of C over little c is going to be equal to the sine of 35 degrees over 8. How we find angle C is by subtracting the 2 angles I know from 180, and that would give me 99.195. And by using a little approximation and plugging in my values and finding little c using my calculator, I would find that my third side is 13.768. And we did that at the top of the page, so you can follow that, and that makes sense. So here, now we have to find the possible second triangle, which is possible. We still have to make sure that that's going to happen. So triangle 2 is going to be my triangle that could be my obtuse triangle. Because here, actually, not really obtuse. I mean, they're both kind of obtuse. We've got to be careful with this because 99 is greater than 100. But there's always 2 possible triangles that you could find. Triangle 2, you have to take the first angle that you found. The first angle we found was angle B. We were given A, but the first one we found was angle B. So we're going to take the first angle found, and we're going to take it, and it's going to be supplementary to the other angle. Now, how do we know it's supplementary? Well, this originally was angle B, right here. And if I look at angle B, and after I add this equilateral triangle, this angle is supplementary to its adjacent angle. And since this angle is a base angle of an isosceles triangle, that's going to be equivalent to that angle as well. So using isosceles triangle and using 2 angles that form a linear pair, we know that these angles are supplementary to each other. So we're going to take the original angle B of the first triangle, of triangle 1, and we're going to take that angle and we're going to subtract from it 180 degrees. When I take that away from 180 degrees, I end up with my angle B of 134 degrees. 134.1, I think it's 95 maybe? Yeah, that sounds right, 195. So that's angle B. That's what I wanted to find. All the other given information, which was already true based on what the problem held, that this was 35, this was 8, this is 10, all that information is still going to be true in my second triangle. However, the measures of angle C and side C are now dependent on the measure of angle B. So we have to go through that process, finding sine of C, which is going to be a new C. That's going to be equivalent to the sine of A, 45 degrees, all over 8. We find angle C by subtracting the 2 angles I already know from 180. So this angle is going to be 10.805 degrees, roughly. And then when I use that to find little c, I can see that little c is going to be equal to 8 times the sine of whatever c is, all divided by the sine of 35 degrees. So that value in my calculator comes out to 2.615. So here's our first ambiguous case where there are two triangles and we can find all of its sides and angle measures. So go ahead now and go through that same process and let's kind of see if we can find our angles and side lengths. Remembering our 4 criteria, or kind of just going through it as a normal process and seeing if this is actually works. So using, if it's side-side angle, which it is in this case, we're going to go ahead and take the law of sine, so sine of 120 degrees over 3 is equal to the sine of b over little b. And we know little b is 4, we know little a is 3, we know sine, measure of angle A is 120 degrees. When I cross multiply and solve for little b, solve for sine of b, I'm going to find that the sine inverse of 4 times the sine of 120 over 3. And when I plug that in my calculator, I get an error message. Now, why would I get an error message? Well, think back here. If I look at this ratio, 4 sine of 120 over 3, if I'm getting an error, that probably means that the 4 sine of 120 degrees is greater than 3, which is a problem, and it can't exist. Also, since this is 120 degrees, it's an obtuse angle. And by my criteria, I can't start with a given angle that's obtuse. So the minute I run into these roadblocks, I realize that no way can this triangle even be formed given the information I was given. So these are not even triangles to begin with. Not triangles. Which makes me very sad. Okay? So again, knowing that we can't form that triangle using that given information, I can just stop right there and state that there are no triangles to be found. So let's go over one more example. I'll leave one for you to try on your own. Example 12 is one of those cases where we can find one, but when we go to find the second one, we run into a little bit of a hiccup or a mistake or a messy situation. So let's go ahead and draw our triangle. Draw something that looks acute for now. We're given angle C. We'll put that right there. Side C opposite is 4. And side B, we'll say is opposite of angle B. So we'll put that here, 3. Looking at that information, angle C at 75 degrees, C is 4, and B is 3. First thing I'm probably going to find is the measure of angle B using law of sines. So the sine of angle B over 3 is equal to the sine of 75 degrees over 4. Cross multiply and then solve for sine of B and then do sine inverse. I know that measure of angle B is going to be the sine inverse of 3 times the sine of 75 degrees all over 4. And we're just doing some really quick cross multiplication and simplifying in our heads to make sure we get to that value. Once I'm standing here, I want to make sure that I get an actual value. And when I plug in this in my calculator, I get an angle measure B to be 46.423. Remember, this is the angle that we found first, angle B, in my first triangle, triangle number 1. So if I'm using this angle B in triangle number 2, I want to make sure that I take away this angle take this angle away from 180 degrees to find the other angle B. Oh, I'm sorry. Yeah, angle B. So when I plug this back in, angle B that I want to find here, when I subtract 46.23 from 180 degrees, I end up with an angle of 133 degrees, 0.5, I think 7.7, my rounding, if it works out that way. It's degrees. So the given information is always true. Can't change that. And we need to make sure we go back and find the measures of angle A. We don't want to skip that process. So the sine of A, which I can find A over A, is equal to the sine of 75 over 4. Do a little cross multiplying. Obviously, we found the measure of angle A by adding up the angles and subtracting from 180. And using law of sines, we realize that this is going to be 3.535. So we have one triangle. This thing works out. This is a real triangle. It fits all my criteria. However, and this is one of my 4 criteria in the original list of things, and that's because of what happens in this next step. Once I found 2 angles and 2 sides of my second triangle, I would go ahead and try to find the third angle, right? So I would add 133.577, and I would add that to 75, and I would take that away from 180 to find my missing angle. But when I do that, I end up with something that has a negative angle measure, which can't happen because 133.577 plus 75 is greater than 180. So you can't find this measure of angle A. So since that's not an angle, or the angle is less than 0, this second triangle doesn't exist. So in this case, when the ambiguous case happens, there is no ambiguous case. We have an original triangle, which we can find, but we can't find a possible second triangle because it doesn't fit all the criteria. Mainly being that 3, looking back at the previous page here, we had defined here where the given side had to be less than this other side that wasn't opposite the angle I'm in. So when I look back here at the next page, here 4 had to be less than 3, but it's not. So since it's not, therefore, we're not going to have that ambiguous case. All right? So go ahead and look at number 13 on your own. You can check it with the key in the notes to see if you got that one right. If you have questions, come see me. We can walk through it together just to make sure that get through that process. Really make sure you try the homework problems, which are posted on the homework page. That practice will be really helpful, and make sure you're treating it as if they were test questions. Good luck, and that's the end of 7.2.